All right, let's do some Mathity-Math. Now, before we get started, I have my pencil, not a pen, because, we need to erase if we make mistakes. As such, I also have my handy-dandy eraser right here. And with that said, let's get started. This is a practice test for MYP1 mathematics. And we're going to focus here on our knowledge and understanding. And let's get to it. So it says for us to find the next two terms in the sequence and also explain our reasoning. And there's some nice hints here that we can kind of use to scaffold this answer. But please remember, on your actual test, I will not give you these sentence stems. You need to be able to do that on your own. Okay, so looking here, we go from 5 up to 10. So we could ask ourselves, okay, is it plus 5 or is it times 2? Well, if it was plus 5, 5 plus 5 is 10. 10 plus 5 is, that's not it. It's not plus 5, so it must be times 2. And you can think of it like this, right? 5, I'm gonna come down. 5 times 2 is 10. Whoop. 10 times 2 is 20, and so on and so forth. 20 times 2 is 40. 40 times 2 is 80. 80 times 2, well, that is 160. And 160 times 2 is 320. Voila, there you go. And when they talk about, when we talk about explaining it, it says after each term, it is blank by blank, right? Or you could just say something like this, right? Like each term, that's a good math word. Each term is multiplied by 2. Right? And to be more specific, what we're saying is like, each next term after the first term. But we just kind of want to understand what's happening term to term to term. Okay, let's go to the next one. Okay, this one, we have a 1, 6, 11. So 1 to 6 is plus 5. Okay, so you can see here it's just plus 5, plus 5, plus 5, plus 5. So 21 plus 5 is 26, right? And then after that, it would be 31, right? So we can let's write a different sentence here, maybe to be a little bit more clear than this one, because we can always kind of improve, excuse me. So I could say each next, hey, say new. Let's say new. I like that a little bit better. Each new term is found by adding, there's a good math word, 5, I'm running out of space, to the previous, that's a good one, previous term. There you go. And again, we're just trying to understand what's happening in between on each one, okay? All right, let's go to the next one. Okay, how does a 96 become a 48? So maybe it's minus 48, but if I do another minus 48, nope, that doesn't work. So let's see, how could 96 become 48? Divide by 2, divide by 2, divide by 2, divide by 2. So 6 divided by 2 is 3. 3 divided by 2 is 1.5. Okay, so what happens right here? So that we can use this one here. It says after each term, it is, so what's our big math word? We would put here, you'd fill in divided by 2, right? And again, on your test, you will be asked to write out a sentence that kind of explains your reasoning or talks about how each term changes. Okay, last one on this section says here, okay, so 50 becomes 40. Okay, so it says minus 10, minus 10, minus 10, minus 10, minus 10. So here's our sentence stem. It says after each term, it is, and we could say subtracted, good math word, subtracted by 10, okay? And that is the first section all done. I'm running out of space. Let's make sure we see that nice and neat. Okay, so here, there you go. That is our first page, first section all done. Let's put in a cool special effect. We're gonna go fiery explosions. So on to the next page. Boom! All right. Says, translate each of the following phrases into a mathematical expression. Okay, so let's also, this is not going to be assessed on communication, but we can always work on communicating and writing information clearly. So we can call this one, for A, 28 divided by a number. So that number is a variable, it is an unknown, and we don't know. So I'm gonna say 28 divided by, and I'm just gonna use X. There you go. If you want, you could also, let's see here, or you could also think of it like this, 28 divided by X. Those are both good answers. You can just choose one. Okay. B, let's see here, it says a number decreased by 4. Decreased means it goes down, so that of course is subtraction. So I would say X, and you could choose any letter you want. You could choose N, whatever. I'm gonna say X minus 4. There we go. Looking at C, it says 4 more than a number. Okay, so we have a number, and then we have 4 more than it. Ta-da! And because of the communicative nature of addition, you could also write 4 plus X. Both are A-okay with me. And last one, D, 17 times a number. 17 times a number. So that means to multiply. So we could say 17 times, let's say N. We don't want to mix up those things. So you can do that. You could write it like this. And again, because of the communicative nature of multiplication, you could also do it like that. Those are all okay. You can just choose one on your assessment. And that's that. Look at us go. Whee! Okay. Oh, wait, you know what? Because I finished this section, maybe we should do an explosion. Here we go. Okay, here we go. We're doing substitution. What an important math skill. It says, so substitute the given number into each expression to find the value of the expression. Okay, so looking at A, we have X minus 12. Now I want to lay out my work really, really nicely so we can see this, okay? So I started with X minus 12, okay? And then when we look at this, what they gave us is they're saying X is 20. What that means is, in the context of just this question, wherever you see an X, you can replace it with a 20. And conversely, wherever you see a 20, you could replace it with an X. So all that's saying here is I'm going to substitute out that X and stick in the 20. And I like to always substitute with parentheses so I can clearly see what I'm substituting. Okay, and if you look at that, you now just say, well, what is 20 minus 12? And that is 8. There you go. And that is that. Let me just draw a little. Let's go look at B. So the problem they gave me is, let me do that, sorry, 15 minus 3x. And again, they've told me, well, x, in the context of this problem, x is 2. Okay, so wherever I see x, I can put in a 2. So my first step is to actually do the substitution. And again, guys, substitution is a great math skill, also a great math word. Okay, so there is my first step. That is my substitution. And now it's saying here I need to multiply. So I have a negative 3 times 2, or you can just leave it as a minus and a plus 3. It doesn't matter. Okay, so let's say now 3 and 2 is 6. I'm sorry, 3 times 2 is 6. So it's 15 minus 6. Okay, and now that we've done that, we just need to solve this thing. And we can just say, well, what is 15 minus 6? Well, that is 9. And you are done. Here we go. Last one, same idea. We're just practicing the skill of substitution. So here's C. I have an x plus 4 over 6. And again, they're telling me wherever I see an x, I can put in a 20. So there we go. I put it in. Looking good. 20 plus 4 is 24. So we have 24 over 6. And well, what is 24 divided by 6? That is 4. And you are done with this page. Move it on. Here we go. Now this one is getting into one-step algebra. Maybe, let's see, is it any two-step? Oh, just one-step algebra. Okay, and so remember here, let's practice our mathematical thinking and using our math words. So when we look at each one of these questions, our goal is to isolate the variable. Let's see if I can do some like video magic here. Our goal is to isolate the variable. If that worked, something really cool should be showing up right here. If not, then I just look crazy. Okay, so we're gonna try and isolate this variable. So we're gonna start with A. We have x plus 25 equals 40. Okay, so for this one, our goal is to isolate x. And right now, x, it has a friend, and this friend is plus 20. The operation is addition and 25. Oh, excuse me, 25. So we need to do the opposite operation and then balance that equation. So the opposite operation here, it had plus 25, now I do minus 25. That is called opposite operations. Now go to the other side of the equal sign, right there, and this is called balancing equations. 25 minus 25 is 0, so the x is here, the equal sign comes with it, and now you have 40 minus 25, and that is 15. Okay, so you're saying that your answer is x is 15. Now, we should check our work. This is like a left-hand side, right-hand side situation, and we should always do that. So the left-hand side, right-hand side is going to be one of these things. My left-hand side was x plus 25 equals, and my right-hand side was 40. And now I've said x is 15, which is me saying we can substitute. Wherever we see an x, I can say 15. So here, instead of x, I'm going to put in 15 plus 25 is 40, okay? And 15 plus 25 is 40, and you get a story here, an equation. It says, well, 40 is 40. Well, 40 is 40. That is true, and that's how you know it is correct. So that is a good job. Okay, very, very good. Okay, and so as a student, you should know that this skill of one-step algebra, it's a big one, and it's going to come back, you know, for the course of your mathematical career as a student, all through high school, and if you choose to go to college, all through college, okay? So we really want to focus on this and make sure we can do this because you will be doing this a lot in the future. So B, I have 7x is 56. Okay. So again, my goal is to isolate the variable. Isolate the variable. And if we're going to do that, we just ask ourselves, well, this is my variable x. It is not isolated because the 7's here. What is that 7 doing? Well, it is multiplying. What is the opposite of multiplying by 7? Dividing by 7. That is called opposite operations. If we do opposite operations, then we do balancing equations. You go to the other side of the equal sign and you balance it out. Okay? 7 divided by 7 is 1, so you get 1x. Well, here's 1x. You can see it, 1x. And bring down the equal sign. 56 divided by 7 is 8. And you're saying, well, x is 8 and 8 is x. Okay, well, if that's true, then we should be able to check our work. Left-hand side, right-hand side. My left-hand side was 7x. My right-hand side was 56. Now I said x is 8, so I substitute. And I want you guys to see how I'm using this math language on purpose. It is a good habit to get into, okay? And here we go. What is 7 times 8? Well, that is 56. Well, is 56 the same as 56? Sure is. Ta-da! Good job. Here we go. Same idea. Let's go to C. I'm going to do this to make sure I have enough space. Okay, here we go. So looking at C, m minus 10 is 11. My goal is to isolate the variable. Okay, oh, I made a curve. I don't know if I can curve. We'll see if it curved or not. Okay, all right. So we isolate the variable, and m is not isolated because what's here? Well, a minus 10. The opposite operation of minus 10 is plus 10. Now I go to the other side of the equal sign and balance that equation. I did it here, I do it there. We are balanced. A negative 10 and a positive 10, they make 0. So now I have m is 11 plus 10 is 21. Good. Let's check. That's why I love algebra, because you can always check. There's real comfort in knowing I can just go check my answer and see what's going on. So I have my left-hand side was m minus 10. My right-hand side is 11. Great. Okay. Substitution, I can put in my 21 minus 10 is 11. 21 minus 10 is 11. Is 11 11? Yep. Ta-da! You are good to go. All right, here we go. The last one on this section for one-step algebra, we have p divided by 8 is 3. Again, our goal is to isolate the variable. My p is not isolated. It is being divided by 8. So what is the opposite operation of dividing by 8? Well, multiplying by 8. And so pay attention here. It's going to look like this. P divided by 8. We're going to multiply by 8. And as a fraction, it would look like that. And this would be that, okay? So I multiplied by 8, and I made it into a fraction by putting the 1 on the bottom, which you can do to any whole number. I mean, any value, really. And then multiplying over here as well. So when these combine, I mean, you're going to actually get something like this. Let's just show the work. We have 8p now over 8 equals 24. Well, 8 divided by 8 is 1. So that just becomes a 1. So we get 1p is 24. And there we go. Okay. So we're saying p is 24. Let's go check. My left-hand side was p over 8. My right-hand side was 3. I said I can substitute in 24. And 24 divided by 8 is 3. 3 is 3. Voila, your work is good. And we are moving on. All right, so now we're looking at two-step algebra. Nothing really different here. You just do more steps, okay? So we're going to go through these questions. And again, in this case, it's just 2 steps. So I have 2x plus 10 equals 16 for A. I'm right here. Okay, so our goal is to isolate this x, but this x isn't isolated because we have, not only is it being multiplied by this 2, but there's also this piece right here, this term, this plus 10. So we're going to always go for the other term first and then address what's happening directly to our variable. So step 1 is we subtract 10. Opposite operations, balancing equations. Okay, so the 2x is here. And now, plus 10 minus 10 is 0, so that goes away. We have our equal sign. 16 minus 10 is 6. Next step. Okay, now we can go for the variable of x. It is being multiplied by 2, so we can divide by 2. That goes away because 2 divided by 2 is 1. So I have 1x equals 3. x is 3. And then going to our left-hand side, right-hand side check. My left-hand side was, and I'm gonna do this kind of in one step because I've already showed you the process. You look up here, instead of 2x plus 10, I'm gonna substitute in my 3 with that x. So my left-hand side would look like this. 2 times 3 plus 10 is 16. 2 times 3 is 6. So now I have 6 plus 10 is 16. 16 is 16. Yes, it is. 16 is 16. That is true. So, ta-da! And there we go. Okay. All right, here we go. Looking at B. A divided by 4 equals 7. Oh, we got lucky. This is just a nice little one-stepper. A over 4. Oh, I see why it is, though, because watch. So A over 4 is 7. Like we did this very similar process previously, all we have to do is multiply each side by 4, because divided by 4, the opposite operation would look like this. A divided by 4 times 4, and this is 7 times 4. Opposite operations, balancing equations. A is 28. Yeah, I don't know why that one's over here. That one seems a little too easy for this section. But hey, take the gift, okay? And then when we check our work, again, I'm coming here, and instead of A, I'm gonna substitute in my 28. So I get 28 over 4 is 7. 28 divided by 4 is 7. Does 7 equal 7? Sure does. Ta-da! And we are cruising. Okay, down to C right here. And this one is now an actual two-step equation. Oh, this was B. There you go. Okay, so here we go. We have 20 minus 2g equals 4. Okay, so I want to get this g isolated. It's not isolated. Gotta take care of this negative 2. But before that, I gotta take care of this plus 20, okay? So the opposite operation of plus 20 is minus 20. And come over here, it's minus 20, okay? So now we're gonna be dealing with some negatives, and that's no problem. We can handle that. So this goes away. 20 minus 20 is 0. So I have negative 2g equals 4 minus 20 is negative 16. Okay, so now I can go for isolating this g. We do that by dividing both sides by the negative 2, which will give me g is, okay, what is negative 16 divided by negative 2? Well, that, a negative and negative when we multiply or divide makes it a positive. So this is positive 8. And I'm going to encourage you to look at our left-hand side, right-hand side strategy, and I want you to go check that by yourself. If it checks out, let me know in the comments. Say, hey, it worked. Or if I got it wrong, say, uh-oh, you messed up. Let me know. And we'll see if we can get a good math conversation going down in the comments. Here we go. Looking at D, same idea. We have 4h over 11 plus 23 equals 15. Again, we want to get to this h. This h has a lot happening to it. It's being divided by 11 and multiplied by 4 and added by 23. So this is going to be a 3-stepper. No problem for us because it doesn't change. You just do it step by step by step. I have a plus 23. The opposite operation is minus 23. Balance the equation. So now everything I didn't touch or change is still coming down, waiting its turn. This goes away, and 15 minus 23 is negative 8. Okay, so now I still want to get to this h, but I'm not there yet because I have this divided by 11, this 11 down in the denominator. Same idea, let's multiply by the opposite. Divide by 11, opposite operation is multiply by 11. That is the opposite operation. Over here, we call it the balancing equation. Okay, so the 11s divide out into a 1, so they're gone. So now we have 4h is negative 88. Okay, now I can go for this h, finally. Now the h is being multiplied by 4, so the opposite operation is to divide by 4. There you go. 4 divided by 4 is 1h. And 1h is, well, what is negative 88 divided by 4? Well, that is a negative 22. And I want you guys, again, to go check this on your own. Let me know if it checks out, or let me know if I made a mistake. And if I made a mistake, can you find my mistake? Let me know. But I think I did okay. I should check it, but this video is getting long, so we got to get moving. Here we go. Ooh, fun. It says, use the 3 equations below to determine the value of the snail, the dragonfly, and the ladybug. So this is just like a visual way to look at algebra. Yeah, fun. And here, what you can do here, you can do this, like you can look at it and kind of figure it out, or you can like really re-represent this with some algebra. Like check it out. Let's call snails S. So I got 1, 2, 3. You could say this. You could call this 3S is 60. Okay, so I have to isolate this variable, divide both sides by 3, right? And what I'm gonna get is the 3's will divide. 60 divided by 3 is 20. So I can say S is 20. So now I know everywhere I see a snail, it's worth 20. Well, let's check. 20 plus 20 plus 20. Well, that is 60, so we know that is good. So we know snails are 20. Okay, so I'm gonna go to this snail and I'll just write it 20. So it says 20 plus something and plus the same thing are 40. So again, I can represent this algebraically, and it can make it a little more clear. So I know that snails are 20. 20 plus, we'll call it dragonflies D. I have 1, 2, so plus 2D is 40. Okay, so this is like 2-step. Subtract 20 from both sides, opposite operations, balancing equations. 20 minus 20 is 0. 40 minus 20 is 20, and I would have 2D is 20. Now I divide both sides by 2, opposite operation, balancing equation. D divided by 2 is, 2D divided by 2 would just be 1D, so you'd have D equals, and 20 divided by 2 is 10. You can check this like we talked about earlier, doing left hand, right hand side. You can also kind of check it right here. So if I said D is 10, so 10 and 10. Let's see. 20 plus 10 plus 10, well, that is 40. We are in business. So now wherever I can put that here. So now wherever I see a dragonfly, I write 10, okay? And this is a ladybug. We'll call those L. And again, some algebra, I could say 10 minus L equals 5. Okay, now this one might be a little tricky and weird for us, but you could also look at it. We could look here, well, 10 minus what? 10 minus what would give us 5? Well, you know L is 5. And we can do that algebraically too. There's just gonna be one little concept you probably haven't seen before, but you know what, let's do it. Subtract 10 from both sides, right? We'll go this fast because this is maybe a little beyond us, but we have negative L now equals negative 5. And the question that a lot of kids struggle with here is, what do I do with that negative sign? And this is where you have to remember there's actually a 1 here. Remember, it's 1L. So that's actually negative 1L equals negative 5, which means we can divide by negative 1. And that's how you can prove that L is 5. Okay, so that would go right here. Let's check. Is 10 minus 5 5? It sure is. If I put the 5 here, let's check. 20 plus 10 plus 5, well, that is 35. We are in business, and we are done. Good job. As always, remember, be safe, make good choices, be kind to yourself, and be kind to each other. Bye.